Hey everyone, I'm Trisha Becker, Developer Relations Lead at Niantic, and today we'll be going over everything you need to know about getting started with our Lightship Visual Positioning System, or VPS as we call it. Building a 3D map of the world has been one of Niantic's priorities from day one, since this is the key to making the real world come to life with information and interactivity. VPS now enables you to place virtual objects in a specific real-world location and to have that object persist, so one person can leave an object for someone else to find, bringing real-world global game boards to life. By the end of this tutorial, you'll be able to create your own immersive AR experience that uses persistent AR content in the real world that users can find and interact with. Now, to understand how VPS works, we'll start by going over its features. VPS has the VPS Coverage API, which lets you discover VPS-activated wayspots near a real-world location, and the VPS Wayspot Anchors API for localizing with VPS-activated wayspots and creating and managing virtual anchors associated with a VPS-activated wayspot. For the purpose of this demo, we'll use the Wayspot Anchors API to create VPS-enabled anchors and save or load them on future app sessions. Now, if you're wondering what wayspots are, these are places and objects that are locally unique, culturally meaningful, historically notable, or just simply worth venturing out to that have been mapped by Niantic's player community according to Niantic mapping guidelines. A Niantic wayspot can be VPS activated, meaning that Lightship VPS will be able to localize with that wayspot. And in order to help you with your development and testing process, Niantic also has the Wayfarer app that enables you to scan real-world locations and submit them to Niantic to be registered as VPS-activated wayspots. You can use the app to create private scans for your own development use, or add scans for public VPS-activated wayspots. In this video series, we'll also be covering how to scan for VPS, so make sure you check that video to learn how the Wayfarer app works, as well as best practices for scanning. You can also check our developers portal to learn more about VPS, the Wayfarer app, and wayspots. Now, let's create a VPS project together. For the purpose of this demo, we've already taken the basic steps to set up our project in Unity with the Lightship ARDK. If this is your first time working with Lightship, or you'd just like to refresh these steps, you can check out our basic video from this Getting Started video series. So let's get started by removing the main camera from the scene and adding the AR Scene Camera prefab that contains all of the scripts that we'll be using in this demo. Now we're going to create the logic and object that will interact within the space using plane tracking. We're going to start by adding an empty object into our scene. I'm calling it AR Game, but you can name it however you'd like. Now let's add the AR Plane Manager script from the ARDK package and then set the plane prefab property with the plane prefab from ARDK library. Remember to set detected plane types to horizontal, as the default value is set to nothing. We'll need to call this detected plane type property for later in the tutorial. We'll use the horizontal planes only to keep the project simple. You could set to any values that you need. Now, we're going to write a little bit of code. VPS experiences require some C# coding skills, so if you're not very familiar with Unity, you can check out Unity's Learning Area, which has tutorials of different levels and focus areas. Just to simplify the approach in this demo, we'll be saving our data locally. However, if you're creating your project, you could also store it in the cloud so you can share it with different users. Going back to our code, let's start by adding a new script component, which we're going to call AR Game Logic. We're now going to create a series of variables to access our session, our camera, and prefabs. Once you've created these, we're going to define them in the Properties panel. Our session property is private and will not show in the Properties panel. We'll be creating it by code through the AR Session Factory. I'm going to use our mushroom prefab, which contains a simple 3D model, but you can use your own prefab if you'd like. To create a VPS-enabled anchor, we need to work on two different workflows using our Wayspot anchor service: creating an anchor and then restoring that anchor. Lightship's Wayspot anchor service allows you to create a Wayspot anchor, which provides a payload that you can then save locally or on the cloud. At a later time, you can also provide the payload to restore the real-world position of that anchor in your current device coordinates. Okay, we're ready to move along. Now, we're going to create an AR session and subscribe to its events. So let's begin by creating our session by invoking the create method from the AR session factory. We need to subscribe to the onSessionInitialized event on the AR session factory. Now that we have a session initialized, we'll run the session with the proper configuration for the experience. To configure the session, we need to create a configuration through AR World Tracking Configuration Factory. In this experience, we need the world alignment to be set to gravity and the plane detection to be the same value as the plane tracker. In this case, that's horizontal. Everything else should be set to false. Don't forget to import niantic.ardk.ar.configuration. We recommend using gravity alignment versus compass alignment to avoid drift issues when using the VPS tracking system. Finally, let's subscribe to the RAN event. We created a function called onSessionRAN for this matter. Remember, you need to import niantic.ardk.ar.any session initialized args, niantic.ardk.ar.AR as well as a niantic.ardk.extensions namespace. Now let's continue by adding our touch events. First, we'll use the platform agnostic input under the niantic.ardk.utilities.input.legacy namespace to get the touch event and touch position relative to the user's screen. With that screen position value, we'll use the current frame hit test method from the AR session to get the collision point on the detected planes. In this project, we're using the pose as a matrix 4x4 to send the full position and rotation to the Wayspot service. Don't forget, you need to import the namespace niantic.ardk.ar.hitTest. Now, creating VPS experiences requires us to rethink the way we normally tackle some flows within our projects. For example, we won't be creating our anchor directly on our scene. Instead, we'll be sending the position to the Wayspot service, and once it's been validated, we'll properly add the object to the scene. So let's create our Wayspot service with the Wayspot Anchor Service class. Now, remember, you need to import niantic.ardk.ar.wayspot anchors. We'll create the Wayspot Anchor service in our onSessionInitialized event. This service needs its own configuration, as well as a session and a location service reference. Cool, so now we've created our configuration, created and started the location service, and finally created the Wayspot Anchor service as well. Creating this service automatically starts the localization process in the background. Remember, you need to import niantic.ardk.locationService to access the class and factory implementations. Lightship VPS uses the device location service, so you'll need to make sure your app has permission to access these services. The ARDK provides convenience classes for handling permission requests. To work with the Wayspot service, we need to make sure our service is localized. To that end, we'll be checking the localized status of the session. So let's create a Boolean variable called initial localization fired to use as a toggle inside of our code and check for the localization status on the update method. In this code, we're just checking if the Wayspot anchor service has been localized to keep the code simpler. But in your production code, you could check for the other statuses: initializing, localizing, or localized and failed. This way, you'll have proper app response for each localization state. Now, we have two checks on the update method. The first one is simply skip any update logic and interaction while the Wayspot service hasn't been created or localized. And the second one triggers a function since the service has been localized. We'll be using this event a few steps later in this tutorial. Now, let's move into allowing users to add an actual anchor to our experience. Earlier in this tutorial, we talked about sending the position to the Wayspot anchor service and adding the object to the scene. So now we're going to create a function called addAnchor that receives the matrix 4x4 pose and sends it to the Wayspot service using the method createWayspotAnchors. This method receives a callback and a matrix pose. The callback method, which is on Wayspot anchors added, receives an array of anchors added to the service. Let's create a property called anchors where we'll save the current anchor ID as well as the game object linked to it. Now let's create our game object and position it. The onWayspotAnchors method receives an array of iWayspot anchors with its corresponding ID for each one. We'll use that ID to check on the anchors dictionary to see if it's been already created. In case it hasn't been created, we'll proceed to create the object in the scene and then add its ID to the anchors dictionary. Now, in this demo, we're not setting the position ourselves. We're subscribing to a TrackingStateUpdated event to set the position. This ensures that our anchor will reposition and update any change on the service. We'll create our objects as hidden and then enable them when we have their correct position. Now we have our project using the Wayspot service to place objects in space using VPS as the decision maker of the experience. To be able to interact with VPS over time, we need to save the anchor payload of our Wayspot anchors and then query on the service once we reload the app again. You can either save that information locally on your device using an API or even on a cloud database. In our case, we'll set up a simple player pref variable where we'll be storing our data as a serialized string. We need to define a key name for our player pref. So in our case, we'll set a variable called local save key with a custom value, my_wayspots. To be able to store the data serialized, we need to define a structure. So let's create a class with a property where we'll store all the anchors. We'll call it myStoredAnchorsData. Now let's create a method called saveLocalReference to store all the Wayspot anchors we created in the current session. This method tackles several things. First, it gets all the Wayspot anchors in the current session. Second, it stores them as a payload in our myStoredAnchorsData. And finally, it saves it as serialized content into the player prefs. Keep in mind that although we're just saving the anchors for this example, you can also save other info that are related to the anchors, like the model, color, text, sound ID, among other things. Let's finish the save process by setting up a call once we've successfully added an anchor to the experience. Let's go back to the onWayspot anchors added and call the save local reference at the end. Make sure you call it outside of the for each loop to do it in one single time per anchor. All right, we're almost there, folks. Just one thing left. Let's add all the anchors we've saved once we start our app. For this purpose, let's create a load local reference method. So this method involves quite a bit of work, but we'll get there, don't worry. The first thing we're going to do is to create our data structure and then deserialize the stored information. Once we have our data, we cycle through it to create a payload list to be queried in the Wayspot service. We're going to call the restore Wayspot anchor service to get all the references from VPS. Note that this can only be done in a localized state. This method handles the creation of events that update the tracking information and alignment into the scene. The TrackingStateUpdated event will now provide updates on these anchors that were restored. And then finally, we use the same method to create our game objects in the scene on Wayspot anchors added. To call this function, we'll need to have our service running and localized. For this demo, we can use our implementation inside the update method that evaluates when the service is localized. So let's add a call before we set our initial localization fired Boolean. That's a nifty little trick. Since we're using the same method on Wayspot anchors added when we create an anchor or load an anchor, the save local references call will occur in both situations. To prevent that from happening, let's use our initial localization fired variable. Since we define its values after we load the anchors, we know that will be true only when you go through the adding an anchor process. So let's use it as a flag to prevent saving on load. And with that little trick, our demo is done. Now you can successfully create your own version of a VPS-enabled experience that allows users to locate objects with precision in the real world. You can test out what you built on Unity's mockup scene and also on your devices. If you need any guidance, don't forget to check out our documentation on the developers portal. So what's next? Well, check out our tutorials page for several tutorials on specific Lightship topics. Then join the Lightship community Discord to discuss projects with other developers. And finally, follow Lightship on Twitter and Instagram to see projects built with Lightship and stay in the know with updates to the platform. Happy building, friends!